So in this video we will talk about VYOS's support of BGP EVPN. Again, a quick overview of EVPN is that if you are extending your layer 2 subnets over an IP network, you can use VXLAN point-to-point, or you can use BGP EVPN for multi-point configuration. So now with VXLAN point-to-point, even though EVPN also uses VXLAN, but if you want to not use BGP, you can use VXLAN point-to-point without BGP with multicast for your flooding or flood list in Arista, which I have the videos for. But if you want to, obviously BGP scales well, so you use BGP EVPN to scale your topology or your network configuration or designs. In this case, now VYOS 1.4 and forward is supporting EVPN. It's not in the mainline, I believe, yet, but I just tested it and was excited to share this with you. Here's my topology. Clear this up. The topology consists of two workstations sitting on the same subnet. 10.1.1. 51 is his address. 10.1.1.50 is his address. /24/24 connecting to the Ethernet ones on both sides on VYOS 1 and VYOS 3. VYOS 1 and VYOS 3 is your VTEP VPN tunnel endpoints. Basically what that does is it takes the layer 2 packet coming in on this interface on VYOS 1, puts then an IP packet and tunnels it. Now I've put the VYOS v4 in the middle, so just for showing that this is over an IP network. So there's only IP network, IP configuration with OSPF configured between the loopbacks and these interfaces right here. So I'm using OSPF to exchange the loopbacks so that I can do BGP peering on these loopbacks. And the configuration of the two VTEPs, V1 VTEP here is right here and V3 is right here, and I'll go through that in 1 second. But essentially on V4, I'm only running OSPF. And on V1 this side and V3 this side, I'm using OSPF with loopbacks. That's it. And then BGP is peering. BGP is only running on V1 and V3 with loopbacks peering with each other. So, and when the L2 packet hits the Ethernet interface on V1, it gets encapsulated and then gets flooded or forwarded to on this interface. The V1 and V3 has bridge interfaces that got the membership of Ethernet 1 and VXLAN interface. In my case, I'm using VXLAN 100 on both sides. The bridge interface has Ethernet 1 and VXLAN 100 on both sides. Very straightforward configuration. If you look at the VYOS 1 BGP configuration, you basically go into unicast v4. You can configure this based on how many paths you have. In my case, I only have 1 path, but I still went ahead and put in 10 just to test it out. Redistribute connected, then you go into the address family L2 EVPN, and you advertise all VNIs. If you want to advertise specific VNIs, you can do that, but I just did all VNIs. Then BGP configuration, local AS 8123, and then the neighbor is 10.003, which is this guy right here. And then next top self on both sides on the unicast as well as the L2 EVPN. Next top, basically, you're saying that anything that I am redistributing connected or packets coming in, I want the inside interface to be my next top instead of the outside interface. Capability dynamic, which is to learn the MAC addresses dynamically. and then remote update source loopback 0. I'm not using the dummy interface as in the documentation. I'm just using the loopback addresses here. And then now the interface is a little note on that. So you got the bridge interface, which has the members Ethernet 1 and VXLAN interface 100. And then this is Ethernet 0, which is this guy here. He's facing the VYOS 4 on this interface with OSPF. And then Ethernet 1, which is this guy. When I brought this VYOS 1 router with VXLAN and bridge interface, the bridge interface MAC address and the Ethernet interface MAC address needs to match. So in this case, in VYOS 1 case, it dynamically did it automatically. I didn't have to tweak it. But when I did the same thing, same configuration, right? But you'll see I had to manually put in the MAC address to make it unique because it was not matching up automatically with Ethernet 1. So I had to manually put it in. So you have to make sure when you test this out, you check it out that your MAC address is matching up with the interface that's connecting to the workstation or end user. That's the tricky part that I highlighted here. And loopback needs to be 32s, both ends. You got that. And then the VXLAN interface is very straightforward. I'm using, standard port. You can use any port you want, but standard port 4789. Source address 10001, which is the loopback, and then the VNI is the VPN tunnel that's coming in from this interface. 100 on both sides. Very straightforward configuration for BGP EVPN. And then when you start pinging, you would dynamically get an ARP go through and get a response back. So that's the configuration, very straightforward. Let me show you the actual workstations. So here's the workstation on this side, and here's the workstation on this side. Workstation with 50. This is the address 50 right here. And workstation with 51. ipconfig 51. And you can also look at the ARP, the hardware address, just to make sure that you see all these MAC addresses getting learned on the VTEP. So this address on this workstation is 2F, and ipconfig, this is 9B and 2F. Now if I ping this address, which is the bridge address is 200 and 100, you can ping that too. But if you ping this guy here, which is 50, is this guy right here. Before I do that, let me show you the ARP. So there's no entries in the ARP yet, right? And if I have to show you the routers, the VTEPs, you will see that the two VTEPs show BGP L2 VPN, EVPN, and you'll see that 10003 has nothing, no MAC address learned yet. Show BGP L2 VPN EVPN, and 1001 has, even though we're neighboring, but we don't have any MAC addresses learned yet. So now once we ping ping 10.1.1.50, and then I do ping 10.1.1.51. Now what you can see here is you got the MAC address learned. Here you did not have the MAC address. Now you got the 1003 with a MAC address learned 9B, which was this guy right here. You learn 9B, and this guy was 2F. You learn 2F right here. So I don't see 2F here yet, but sometimes it takes a little time, or you just have to go through the pings constantly. To see the MAC addresses that you're dynamically learning. .10.01, this is 2F right here. There you go. And 9B right here. So you got to look at the loopback addresses and then see the MAC address that you're learning from both sides. There's another show. This was BGP, and you can also, there's an EVPN command as well, which shows the MAC, VNI all. Here you go. Show EVPN, MAC, VNI all. And you can see the MAC addresses local and remote. So that pretty, the only note that I would put in is that once I configured this, it took me a reboot to get this thing going, and I'll share you the configuration again. Show protocol BGP, straightforward. Show protocol BGP, straightforward, just like I shared it with on the diagram. And then show interfaces. Show interfaces. Pretty straightforward. The only catch to make this working on obviously a virtual environment, hopefully it won't happen on a physical environment, but since I'm running VirtualBox, the MAC address uniqueness is flaky, and so you just have to make sure that you match up your MAC addresses in your VirtualBox to make sure the Ethernet interface that's receiving the L2 packet has the same MAC address as the bridge interface. And if it's not automatically, then you just have to configure it. And that's how you get your EVPN working. Hope this helps.